So, in the previous lecture, we discussed about solid waste management and air pollution and its control. In this lecture, we are going to discuss about noise pollution and its control. Initially, noise is defined as the unwanted sound. Sound is produced by alternating pressure changes in the air caused by various reasons. So let's start our lecture. Noise, it is defined as a unwanted sound. If you see the characteristics of sound and its measurement, sound is produced by alternating pressure changes, in the air caused by various reasons. Sound waves propagate in the form of sinusoidal path as shown in figure. Here you can see the sinusoidal path. Here it shows the zero pressure line. It is the highest peak value, that is the amplitude. Okay. So simply we can say that noise is nothing but a unwanted sound. This sound is produced by alternate pressure changes in the air. Okay. So the amplitude of the sound wave is expressed in units of pressure such as Newton per meter square. So pressure, same thing here. The units also, the amplitude of sound wave also same units. Pressure force by area, same units. The equivalent pressure of the opposite sine wave is represented by root mean square pressure, that is P pressure RMS, that is root mean square pressure. Okay. Generally, when the sound waves are periodic, regular, and of long duration, they produce a pleasing effect, and such sound is known as musical sound. When the sound waves are periodic, regular, and long duration, they produce a pleasing effect, and such a sound is known as musical sound. When the sound waves are non-periodic, irregular, when the sound waves are non-periodic, irregular, and short duration, they produce a displeasing effect, and such sound is known as noise. Here you can see the difference here between the noise and musical sound. When there is a periodic, regular, and long duration, that is musical sound. When non-periodic, irregular, and short duration, that is nothing but a noise. Okay. The noises that pose the greatest threat to the human body are those which high pitch, high amplitude, and longest duration. So these are the main threats for the human body: the high pitch, high amplitude, and longest duration. Coming to the next slide, measurement of sound. Generally, the sound is measured in units called decibels. Generally, the sound is measured in decibels. The sound is measured in terms of decibels. Important thing, 1 decibel unit is approximately the smallest change of sound intensity which the human ear is able to appreciate. That means when the human ear is able to hear 1 decibel unit, the pressure waves which our ears detect are classified as audible sound, which is ranges from 0.00002 Newton per meter square to 200 Newton per meter square. The sound becomes louder as the pressure increases. The pressure at which the sound first becomes audible is known as the threshold of hearing or beginning of feeling. Here you can see that first thing is that sound is measured in terms of the decibels. First thing, our ears can detect the audible sound from up to 200 Newton per meter square. Another thing is that the pressure at which the sound first becomes audible is known as the threshold of hearing or beginning of feeling. Okay. Next, if you see the for healthy ear, the normal threshold of hearing for a healthy ear is about 20 micropascals. Okay. The threshold hearing is nothing but 20 micropascal. The ratio of two pressures is known as sound pressure level. SPL, that's nothing but the sound pressure level. Ratio of two pressures is known as sound pressure level. Very, very important. The sound pressure level is indicated by formula 20 log base 10 with respect to the pressure of sound wave and reference pressure here. Very, very important formula. Sound pressure level 20 log base 10 and ratio of pressure to the reference pressure. Here SPL is equal to sound pressure level in decibels. Okay, and P stands for pressure of sound wave in Newton per meter square and reference pressure in Newton per meter square, that is 20 micropascal. The standard we can take as 20 micropascal is the standard reference pressure. 20 micropascal. The threshold of hearing 20 micropascal is usually taken as the standard reference pressure. Okay, understanding here, the sound pressure level is equal to 20 log base 10 pressure of sound wave by reference pressure. This reference pressure is nothing but the threshold of hearing. Threshold of hearing nothing but the pressure at which the sound first becomes audible is known as the threshold of hearing. The threshold of hearing will be the 20 micropascal. That threshold of hearing is taken as the reference pressure here. Okay. Let us consider an example. A generator emitting sound of pressure 100 microbar. What is the noise produced by the generation in decibels? See, we know that sound pressure level formula, sound pressure level is, so I told you that sound pressure level is defined as 20 log base 10 with the pressure of sound wave to the reference pressure. The reference pressure will be taken as threshold of hearing as a standard reference pressure, that is 20 micropascal. Okay, so here in this given problem, the given pressure is 100 microbars. Okay, 1 microbar is equal to 10 power 5 micropascal. That means 1 bar is equal, generally bar is represents the units of pressure. 1 bar is equal to 10 power 5 Newton per meter square. 10 power 5 Newton per meter square. Newton per meter square or Pascal, both are same. Okay. So here 1 microbar is equal to 10 power 5 micropascals. We know that sound pressure level in decibels is equal to ratio of pressure to reference pressure. By substituting this pressure value here, we'll get the sound pressure level will be 113 decibels. Okay. By using this sound pressure level formula, we can calculate this. Okay. Next, next, average noise sound pressure level. This average noise sound pressure level is sounds emitting different sounds at different time periods. Then average sound produced by the source is given by 20 log base 10 into 1 by n. Here summation of 10 power ln by 20. Here LP is nothing but the average value of various recorded sound pressure levels at the rate of particular place over a given period. Okay. If we have a source emitting sounds at different time periods, then average sound pressure produced by the source will be this formula. Very very important. Okay. That is about the average noise sound pressure level. Let us see another example. A generator emitting a sound of pressure 800 microbar. What is the noise produced by generator in decibels? Same here also. Here 1 microbar is equal to 10 power 5 micropascal. 800 microbars is equal to 800 into 10 power 5 micropascal. Then sound pressure level in decibels is equal to, by substituting formula, 20 log base 10 pressure of a sound wave by reference pressure. Reference pressure is nothing but the P naught is equal to, we know that P naught is equal to 20 micropascal. By substituting these values here, we'll get the 132 decibels. Okay. So same formula, same problem, previous only. Next, coming to that, effect of noise in human beings. So generally, noise level here indicated in decibels, and what is the effect observed? For 0 decibels, threshold of audibility. Okay. 120 decibels, pain threshold, and major for 190 decibels, major permanent damage is prolonged. So what is the audibility of sound means? 20 micropascal, that is nothing but that here given in noise level is 0. For threshold audibility, for pain threshold, that is 120 decibels. For major permanent damage is prolonged means 190 decibels. Okay. Coming to that, acceptable noise levels for different structures. Here you can see that for auditoriums and music rooms, acceptable noise level is 35 to 40 decibels. Small offices, courtrooms and libraries, the noise level is 40 to 45 decibels. For schools, 45 to 50 decibels. Large public offices, banks and stores, 50 to 60 decibels. And for factories, 60 to 65 decibels. Okay. These are acceptable noise levels for different structures. These are very very important. Try to remember these values, decibels. Okay. Depending upon the duration, the noises can be also be grouped in the following 3 types. One is the continuous noise, intermittent noise, another one is the impulse noise. Okay. Continuous noise is an uninterrupted sound level that varies less than 5 decibels during the entire period of observation. A running fan is an example of such a noise. Okay. So continuous noise means an uninterrupted sound level that varies less than 5 decibels during the entire period of observation. Example is running fan. Another one is a intermittent noise, a noise which continues for more than 1 second and is then interrupted for more than 1 second. A drilling machine is used by dentist, such type of noise. See here, a noise which continues for more than 1 second and interrupted for more than 1 second, that type of noise nothing but the intermittent noise. Example is that drilling machine. Okay. Coming to the third one, impulse noise. Impulse noise, it is characterized by a change of sound pressure of at least 40 decibels within 0.50 second with a duration of less than 1 second. Okay, this is nothing but the impulse noise. That means sound pressure at least 40 decibels within 0.50 seconds with a duration of less than 1 second. Example, we can say that firing a weapon indicate that such a noise. Okay, so that's all about the noise pollution. Generally, this noise pollution can be prevented by taking some of the measures for effective control on the noise pollution. One is the design of doors and windows. Generally, the excellent sound insulation is obtained by constructing glazed windows with double or triple planes of glass. Okay, by constructing glazed windows with a double plane of glass, we can effectively control the noise pollution. Okay, one is the design of doors and windows, and second one is the enclosures. So generally we have to provide enclosures, shields and barriers so that some of the sound waves are cut off from propagating. Okay, third one, planting of trees. Generally the presence of tree act as noise barriers. Okay, so these are the some of the effective measures is required to effective control of the noise pollution.